Okay, we're finding the derivative of this function, and to do this, we're going to use the chain rule. All right, so this is a chain rule problem. And when we use the chain rule, what we try to do is look for a composition of functions. And what I start off is with something on the inside. Well, and which is a very imprecise term. You know, what does it mean inside? But I'm highlighting the 5x plus 1, and I am going to call that u. So that's one function we see there. Now, if I ignore the 5x plus 1, which I feel like I can do maybe, or show that by shading that in a dark color. For a moment, I'll erase that. But I shade that in a dark color, and I write this is y equals the square root of x. Okay? So, essentially, the chain rule says that I find the derivative. Well, that's not right. Sorry. I should write y equals the square root of u. Okay, because u is 5x plus 1. Now, essentially, the chain rule is saying that I take the derivative of each of these functions and multiply them together. That's the chain rule. Now, before I take the derivative of this first part, I'm going to write this as u to the 1/2. Right? We more or less always want to do that. Now, when we're doing the derivative. Now, I can separately find the derivative of each of these and then multiply them together. I'm not going to do that here. What I'm going to do is I'm going to do that. I'm going to use the chain rule, but I'm not going to show the work of the derivative of each of those two functions separately. Okay, so what I mean here is I'm just going to simply look at this outside function, u to the 1/2, and I'm going to take the derivative right below here. So the derivative of u to the 1/2 is 1/2 u to the 1/2 minus 1, which is negative 1/2. That I think we can do in our head, but I didn't in this case. Okay, so I ignore that 5x plus 1, and I take the derivative of u to the 1/2. And if I want, I could do that above, show that above also. It starts getting sort of messy the more things I write down. But I go back and write the inside, 5x plus 1. So what I did here, this piece that I'll highlight in green, line green, that's the derivative of u to the 1/2 power. That's what that is. U is 5x plus 1. Now I continue by multiplying by the derivative of u. And what's the derivative of u? That's something we can do pretty quickly. It's 5 times the derivative of x, which is 5 times 1, plus the derivative of 1 is 0. So we get times 5. I made a bunch of space there for some reason, thinking I need it, but no, I don't. Okay, so what's that? That's the derivative. So let me point out that I can stretch this whole thing out. I can write, well, the derivative of y with respect to u is 1/2 u to the minus 1/2. The derivative of u with respect to x is 5. And what I'm getting then, when I do the chain rule, is multiplying those two together. All right. From now on, all there is just a little bit of simplifying. Y prime is 1/2 times 5, so that's 5 halves. 5x plus 1 to the negative 1/2. With radicals, it's pretty common to, if I have a 1/2 power, it's common to rewrite that as a square root. But I like to see what the author does. I don't always require that at all. And I'm not going to do it if it's a 4th root or a 3rd root. Okay, I made a little mistake there. Okay. The fact that it's a negative power, 5x plus 1 to the negative 1/2, sends it down to the denominator if I want. And then the fact that it's the 1/2 power means that I could, if I want, write that as a square root. It's it's maybe some idea that square roots are easier to read. Otherwise, I'm thinking, why do I even want to write a square root? Why don't I just write it to the half power? But that's sort of style and maybe even almost a philosophical question. Okay, I would just say that in general, the way I would do this on my own is I would not write all that stuff that I have written above. I would just start. See, I have this green line. This is where and I'm making a box. Okay, this is sort of the problem I would show. That's what I would do. As far as y equals u to the square root of u, y equals u to the half, that's good. You can do that. It might help. And and actually maybe it even helps if I organize it a little better. If I put that derivative right below and then put this over here. So what you do is you can write the inside function and the outside function, take the derivative, and then the chain rule says that you multiply those together. dy dx is is dy du times du dx. Sometimes it's useful to show all that work, but often it just starts seeming like too much, like I would say in this case. So you do that, and then you put in what u is. You can do all that stuff, but for the most part, I would say that looks like a lot of space. It makes it look way more complicated. Brother. So you could do it that way. But what I have in green here is what we want to do usually. But just keep what in mind. What we have is we have the two functions, y equals u to the half, u equals 5x plus 1. We find the derivatives of each of those, multiply them together. That's the chain rule. I don't know what else. I feel like I've written down just about everything there is to write down on this problem. All right, so that, I guess, finishes this video. All right, goodbye.